the slope because it's not a straight line. However, the derivative allows us to salvage this idea by assigning a certain slope at each point rather than a certain slope for the entire graph. The question is, though, how do we do that? How do we actually tell which slope we should assign at each point? Basically, the idea is that if we zoom in really, really close, any curve is going to start looking more and more like a straight line. And then we can just take the slope of that straight line and say that's the slope at that point, or that's the derivative at that point. So for example, around the point 0, 0, you can see what happens if I zoom in a lot. So let's zoom in. Here we're zoomed in about 10 times. Here we're about 100 times. Here we're zoomed in about 1,000 times, 10,000 times. Basically, if we zoom in a lot, and again, what is a lot? You can see here that this line, when I zoom in this far, literally looks like the function y equals 0. In fact, if I told you that you were looking at y equals 0, you would probably believe me, because that's what it actually looks like. So what's the slope of a line y equals 0? Well, 0. It's just horizontal. So we would say that it makes sense to say that the derivative, or the slope, we just zoomed in a bunch. Now, if I go up to, say, another point, let's say maybe around 1, now I'm going to do the same thing, just zoom in 1,000 times, or 1,000,000 times, in about 1,000 times at this point. Now the question is, what is the slope here? Hopefully you can tell by looking at it. You can kind of look at the squares here in Desmos. Again, there's like smaller squares inside of the larger squares, but whichever one you want to look at. If you look at this, doesn't it make sense that we're going over 1 square and we're going up 2 squares? So the rise is 2 and the run is 1. Rise over run is slope, 2 over 1. So the slope is 2 here, basically, is what we're saying. Y equals x squared. It looks like when we zoom in around the point around the point 1, 1, the slope is 2. If I zoom out a little bit more, and let's change this to 2. So if I change that to 2, we can do the same thing. Again, same curve, we're just zooming in at a different spot. So now let me zoom in here. So zoom in. Zoomed in about 1,000 times right now, and let's ask ourselves, what is the slope? So, and actually, probably look better like this. So if you're looking at the larger squares, we're going to the right 1, and we're going up 1, 2, 3, 4. So rise is 4, run is 1, rise over run 4 equals 4 over 1. So the slope is 4. So apparently, on this curve at x equals 2, f of x equals x squared, at the point 0, 0 has a slope of 0. At the point 1, 1, if you zoom in far enough, has a slope of 2. And at the point 2, 4, if you zoom in far enough, has a slope of 4.